Welcome back to part 2 on polar coordinates. Let's take a closer look at the different ways you can represent a point on the polar coordinate system. The coordinates r theta and negative r theta plus pi represent the same point. Let's look at the sketch below. Here we have a blue arrow along the polar axis, and we have a point at, it looks like maybe pi over 6 as the radian measure or the angle, but we'll just call this r equal to 1 unit. There's no scale on it, so we don't need to worry about making it too fancy. But we do need to point out that if we were to take this angle pi over 6 and we were to make the radius negative, we would be over at this point here. This would be negative 1 comma pi over 6. And over here we would, in the positive direction for the radius, we would just have 1 comma pi over 6. To get from this point negative 1 pi over 6, all we would have to do is add an angle of pi, and we would be right back at this other point. And if I wanted to try and draw this, let's see if I can do this here. It would be swinging the point around to this other point. So saying that we have negative 1 comma pi over 6, this point, when we add pi, we would come back to 1 comma pi over 6, that point. So we can say that this point here at 1 pi over 6 is equal to negative 1 comma pi over 6 plus pi, which would be 7 pi over 6. We could also say that negative 1 comma pi over 6 is equal to 1 comma pi over 6 plus pi. Also keep in mind that because of the coterminal angles, each point has infinitely many representations, because we could go around the circle a million times and we'd still have infinitely more times we could spin around it. So this is just kind of an interesting concept, and it's possibly going to take you a few times to think about how you can have these equivalent coordinate points, and there are infinitely many of them, which is kind of cool. So the point r theta is the same as r theta plus 2n pi, and the point negative r theta plus 2n plus 1 pi. So if I think of n as being an integer, then if I have an even number of rotations plus 1, that will always give me an odd number of rotations about the axes, the polar axes. And then if it's times pi, it means we'll have 1, 3, 5, 7, etc. rotations. So the angle plus an odd number of rotations will give us equivalence. Let's graph 2 comma pi over 4. We know that with pi over 4, we will go from an angle along the polar axis up pi over 4 radians, and we'll call 2 steps in that direction 2 units, and there's my point. The point is 2 comma pi over 4. And now it says find 2 other polar coordinates representation with r greater than 0. So we can't use negative radiuses. And 2 with r less than 0. That's meaning we can use radiuses that are less than 0. Another positive radius would be 2 comma pi over 4 plus 2 pi, which would be 8 pi over 4 plus pi over 4. Just getting a common denominator here. That would be 9 pi over 4. Another positive one, we could just add another 8 pi over 4. So that's going to give me 9 pi over 4 plus another 8 pi over 4. That's 17 pi over 4. And the radius is still 2. Now let's look at negative radiuses. Remember, if I want an equivalent negative radius, that means that the point I was at would be pi over 4, but in the negative direction. So I'd be sitting off here on this side, but I don't want to be over here in the third, what's equivalent to the third quadrant in the Cartesian coordinate system. I want to be over here in the first quadrant, and so I have to add pi. An equivalent negative radius, -2, would be pi over 4 plus pi, which would be 5 pi over 4. Now I'm just going to add 2 pi to this 5 pi over 4. 2 pi is equivalent to 8 pi over 4, which means I'll add 8 pi over 4 to 5 pi over 4, and that will give me -2 comma 13 pi over 4. And lastly, -2 comma 13 pi over 4 plus 8 pi over 4, adding another 2 pi to this, will give me 21 pi over 4.